Welcome to my channel. This video I'm going to explain about infinite bases in vector space of polynomials. In my previous video I have given the example for bases as well as the examples. I have given the link in the description box. If you want, you can go and check and learn. So here the problem is being given as show that the infinite set S is equal to 1x squared etc x power n is a basis of the vector space f of x of polynomials of the field f. That means here the set S is going to be an infinite set having the elements like this 1x squared powers x squared x power etc x power n is an infinite set. And then given vector space is going to be the set of all polynomials, that's going to be f of x. Each element in f of x will be a polynomial and it is a vector space already done. Now the solution is we need to show that S is going to be linearly independent. That means to be a basis, there are two conditions. S has to be linearly independent and S must span f of x. So the first condition is that S has to be linearly independent. Let me take a finite subset S dash as x power m1 and x power m2 etc x raised to m power n be any finite subset of S having n vectors. So we have from the infinite subset, we have taken a finite subset which is going to be of this form and it has n vectors. Here m1, m2, etc. mn are some non-negative integers. Let a1, a2, etc. an be scalars such that a1 x power m1 plus a2 x power m2 etc. a power n x power mn equal to 0, which is 0 in the sense here the 0 is going to be a 0 polynomial. To show that S is linearly independent, this equation we need to use and we need to show that the scalars are going to be 0. So since it's a 0 polynomial and according to the definition of equality of two polynomials, any two polynomials be equal in the sense obviously their scalar must be equal and hence we get a1 equal to a2 equal to etc. a1 should be equal to 0. So all the scalars here is going to be 0 and hence every finite subset of S is linearly independent and hence S is linearly independent. Now the next condition is we need to show that S spans f of x. So for S span f of x, each polynomial in f of x can be expressed as a linear combination of finite set of number of elements in S. So for that, let us take a polynomial f of x is equal to a0 plus a1x plus a2x squared etc. a power r x power r be a polynomial of degree r. So instead of a0, a1, you can take any scalar b0, b1, etc. So any f of x is going to be a polynomial will be of this form. And this could be able to express in terms of a1x, a2x squared, etc. And then here this a0 1 into 1, 1 is nothing but x power 0, then x power 1, x power 2, etc. up to x power r for all a in f. This means all f of x can be expressed as a linear combination of finite number of elements of S and hence S spans f of x and S is the basis of f of x. S is linearly independent as well as S also spans f of x and hence S is going to be the infinite basis for the given vector space f of x. Thanks for watching. See you in the next video. Please like and subscribe for more videos.